Hey everyone, and welcome back to another video. In today's video we are going to learn how to lazy load images into your web application. We are going to cover some different techniques, and we'll also consider even Internet Explorer 11 to see how we can effectively lazy load images in the web application, which boosts up the speed of the page load for your web application. If you have not subscribed to the channel, do it right now, and if you like this video, give this a big thumbs up. Without further ado, let's get started. Alright, so the first thing that you need to do is to clone the repository. Let me show you how. So you're gonna go to this repository, which is github.com/snir/fun with JavaScript, and then you go here and then you copy this link. Then you need to go to your terminal and type git clone and then paste the link here. And once you have done that, you should essentially have this folder created by the name fun with JavaScript. You navigate into that and then you switch to the lazy load images branch, in which we have this exercise that we are working on. So you'll do a git checkout and then lazy load images, and once you are done with that, you should be able to see the branch changed. Now to install the dependencies of this project, you need to run npm install, and this should load all the node packages that are required for this project. Once done, you need to open this project into your favorite editor. For this exercise, I'm going to be using VS Code, so let's get into it. So if we have a look at the project right now, you should see that inside the source folder, we have this lazy load images folder, and inside that we have the index.html, which has some HTML inside, and then we have this script.js, which basically calls this main method, which in turn calls the generate images, and this essentially generates the images that I'm going to show you in a bit. The second file, which is JavaScript file, is the card item.js. So this is sort of a component file similar to how we have in React, but this is not actually React. This just returns a string from here for each card item, and then we assign this string using the inner HTML to each HTML element in our view. But I'm not going to go into how this works, but I'm going to go into how to lazy load the images in this exercise. We also have this loaders.css, which contains some styles, and then we have the main style CSS file, which is kind of handling the layout for us. So now that we know about the files, you would want to start the webpack server. So you'll go to your command prompt in VS Code or just your normal terminal, and then just type npm start. This should essentially start the webpack server, and this will also look for any changes in our files so we can see them right away on the browser. So on your browser, you now need to go to localhost 8080, and there we can select the project that we are interested in. So you will see a list of different projects that we have in this Fun with JavaScript series, and then you click lazy load images, and this is the project that we are going to work on. So as you can see, we have a bunch of sections on the page. In total there are 6 sections, and each section has a card with another element. So the other element could be either an icon or it could be a text, but in each section we have a card, and each card has an image, and we are going to make sure that these images of the cards, they are lazily loaded. So if I go to the Chrome DevTools from here, go to network tab and refresh, you can see that we load all the images at once. So even those images which are not shown on the UI right now, so if I scroll down, you can see that there are no more images loaded because we load all the images up front when the page loads. Now the first technique that we are going to use for lazy loading images is the native loading attribute on the image tag. Now just a disclaimer that this whole video is highly inspired from this article on web.dev, which is about browser level image lazy loading for the web. So it also contains a bunch of techniques that you can read there, but I'm going to be moving with a hands-on approach to show you actually how to implement this. So in order to implement the browser level image loading with the first technique, let's go to the code, and in the code we need to go to the card item.js, and here where we have the template for this card item, all we need to do is to add an attribute to the image element, and that is going to be loading, and then we need to provide this the value lazy. Now what this does is that this tells the modern browser to load this image lazily, so it won't show it until you either scroll to the image or there is some threshold involved as well. So if you are, let's say, on the top of your page, it will kind of load 2 to 3 images based on some threshold, and this is different in different browsers, and you can read all about that on the article that I just showed you. So if I now refresh the application, you can see that we only loaded 3 images, and these are the top 3 images, so to say. You can see 121, 122 and 120, and now if I go down, you should be able to see that we are loading more images like 123, 124, 125, and all the images are loaded now. Now notice that if I refresh the application at this point, when I've scrolled all the way down, the browser persists this information, and now it loads the images in the reverse order, that is the bottom 3 images. So you can see 124, 23 and 25, and if I scroll up, we should get 122 exactly, and then 121 and then 120. So you can see that this is the native support for lazy loading, and you can see that this is super easy, right? So I just needed to add one attribute, and the modern browsers now work with this. Now there's another problem, that lazy loading just like this is not supported by other browsers, for instance Internet Explorer 11. So for such browsers, we are going to use a second technique, which is using the intersection observer. The intersection observer essentially looks at the element or observes the HTML element, and then it makes sure that it provides you the value if that HTML element is in the viewport or outside the viewport. And when we have something in the viewport, we can programmatically assign the source attribute of that image, so it loads the image at that particular moment and not before it's in the viewport. So let's implement that technique in the code now. So in order to do that, what we are going to do here is that first we are going to replace this source attribute with data-source. This is one way of providing attributes to any HTML element, because we can get this value in the JavaScript using the dataset attribute or using some other techniques as well. So first of all, we are going to rename this to data-source, and once we do that, you will notice that the images will not be loading. So if I refresh now, you can see that no images load because we don't have the source attribute assigned, we have the data source attribute assigned right now. So going back to the code, I'm going to go to script.js, and here we are going to create another function for the fallback. So we could say const image lazy loading fallback, and this is going to be a function, and then we need to call this function from the main method here. And now first we are going to check if the attribute lazy loading is supported in the browser or not. So we are going to say if loading in HTML image element dot prototype, and this essentially would return true if this feature is supported by the browser, and it will return false if not. So what we need to do here is that we need to essentially get all the images from the DOM, and then we need to apply the value of data source to the source attribute, which we don't have right now. So here what we are going to do is first get all the images. So we can say const images equals document dot query selector all, and using the query selector all, what we are going to say here is that we can say image with data-source attribute, and this will essentially make sure that we get all the images which have this data source. But we also want to make sure that we are only getting images which are supposed to be lazily loaded. So instead of that, we are going to actually use this value, which is loading equals to lazy. So we are making sure that we are only fetching images which are to be lazily loaded. Now that we have this, we need to run a for each loop, or in order to just provide browser compatibility, I'm going to use a simple for loop. So what we are going to do here is that we are going to simply say this array is essentially images. So we are going to say images, and then we have image here, and then we are going to just say element dot source equals, and then we are going to say element dot data set dot source, and this should essentially provide the value for all of these elements and then assign it. Now that we actually have this, let's try this out and see it on the browser. So refreshing the page, you can see that now we are getting the images. So if I just clear this out, go to source and then open the JavaScript file, and I'll put the breakpoint here and then refresh, and you can see that it came here. It should be able to find the loading inside this HTML prototype, and once it does that, it gets all the images. So you can see that we get 6 nodes here, and inside you can see that we get the value of the dataset.source, and then we assign it to element.source, which right now is empty, but it gets its value from here and then assigns it to the image text. And once we go through all of those, you should be able to see that once we expect each image, we have data source attribute as well, and then the source attribute which essentially loads the image. Notice that it is only assigning the source attribute, but the browser automatically is lazily loading these because of the lazy loading attribute. And if I scroll down bit by bit, you can see that the lazy loading is working perfectly fine. So we have actually not used IntersectionObserver yet, but we have just put the basic functionality for the modern browsers right now. Now in order to implement the IntersectionObserver, we are going to put another condition here, and then here we'll first create the observer, and then we are going to then observe all the images at once. So I'm just going to copy paste this code because we are going to essentially use this, but instead of image loading lazy, we are going to now use data-source src, so we are only fetching the elements which have this data source attribute applied to it. All right, now that we have this, what we want to do is, instead of just assigning this source, I'm going to remove this for now. We are going to put some code here which will include the intersection observer. So now let's try to create the intersection observer here. So I'm going to say const observer, and here we are going to say new intersection observer. This essentially needs a function with 2 arguments, which is entries and the observer itself. And then this function essentially will do some magic here. So we are going to loop over all the entries and actually filter them out before we jump into each entry. So we are going to only look into an entry that is intersecting, which means that it is in the viewport right now. So we can filter it based on entry.is intersecting, and then we are going to run a map over the entries which are filtered from here. So we are going to say entry, and then for each entry we are going to do some magic. So we can say first, let's get the image out of the entry. So we can say image equals entry.target, and then we need to get the value out of it of the data source attribute. So we can say const data source value, and then we are going to say image.get attribute. Now you can see that here we are using a different technique for getting the value of data src attribute. So we get the value out of here, and then we check if we have a value for this variable or not, which means that if the image has this attribute and a value, then we are fine. But if that's not the case, then we'll just return from here and don't do anything. Now once we get a value out of this, in which case we'll not go inside this block. In that particular case, we are going to say image.src equals data source value. And once we are done with that, we essentially need to unobserve this image, which should be this code. So I'm going to type observer.unobserve, and then we are going to use the image here. Now for the sake of explanation, I'm just going to comment this out for now, so we can see what happens if we don't unobserve an image. Now that we have the observer in place, we are going to go here, and then we are going to say observer.observe, and here we are going to provide the element. And just for the sake of simplicity, I'm going to actually rename this to image, and here I'm going to post image as well. Now for the sake of example, we are saying, hey, let's suppose that Chrome does not support the loading attribute out of the box. So we are going to negate this condition for now, and we'll change it back later on. So let's save this and try this out in the browser. So upon refreshing, I can see that we have an error here. Let's see where this takes us. So we have this image, so let's fix this one. I'm going to go back to my code, and here we have this image that we should be using. So I'm going to use this, save this, and try this out again. So upon refreshing, you can see that now we have the image being working. So I'm going to refresh again to show you what happens. So in this case, since we are negating this condition, it's going to go here and create the intersection observer, and then I'm going to just put breakpoints here and here, actually not there at the moment, but just here. So it will go and fetch all the images, which should be what we get here. For some reason the browser doesn't show it at the moment, but if we go inside the loop, we should be able to see images one by one. So we'll get the particular image that you can see here, and then we are observing the image using the observer. Alright, so all the images are going to be observed. But then if I put a breakpoint here, so far you can see that we only have one image load, which is much more optimized. And if I scroll down, you can see that it immediately comes under this observer for the particular entry. So you can see that we are getting the entry.target, and if you see highlighted it here at the very bottom, you can see that it highlights the next image because it just came into the view. So if we go forward, you will see that we'll get the value of the data source, which is for the next image, and then we go forward and assign it to the image source, right? So if I play it out, you will immediately notice that the image got loaded right here. So if I try to do this again, clear this out, go to network tab, and if I go down, you will see that as soon as the image comes in, it will be loaded. So here you can see that it immediately got loaded. So if I go further down, you can see that all the images work. Now there's one problem. If I scroll up, you will see that we still load more images, and the reason for this is that the images are again being observed and they are assigned the value again and again. And since I'm using an API that provides a random image each time, therefore the images are loading again and again, and we don't want that, because in a real world application you would have the same value for the image source all the time. So I'm going to go back to my code and just uncomment this out. So we are unobserving the image after an image has been loaded through this observer. So if I go back to my browser and refresh, you can see that we have an image loaded, but if I scroll down we have more image loaded, and if I scroll up we'll get all the images loaded at once. Now if I scroll down you can see that we are not loading any more images because we already have done that. So this is a really good way to make sure that we are not unnecessarily loading all the images one by one. So this is the second technique for you using the intersection observer. Now this technique will not work into some browsers including Internet Explorer, and I'm going to show you that, but before that I just want to make sure that we are kind of putting this condition as it should originally be. So now that we have this and we have the intersection observer in place as well, let's try this out into IE 11. So in IE 11, if I refresh, you can see that none of the images get loaded, and the reason for that is, first, it doesn't support the loading attribute, and second, it also doesn't support the intersection observer. And we can see all of this information from the caniuse.com website, so you can go there and type intersection observer, and once you do that you should be able to see that IE 11 doesn't support it. Similarly, Opera Mini doesn't support it, and there are other browsers which also do not support it. So if you have an app and you have a market which uses IE 11, you might want to consider the third technique that I'm going to show you as well. Similarly, you would want to take a look at the lazy loading attribute for images and iframes and the support for it as well. You can see that here the IE 11 doesn't support it, the Chrome supports it, Firefox partially supports it because Firefox only supports the images and not iframes, because we can use the lazy loading attribute for both iframes and images in the modern browsers. You can see that the Edge supports it, and you can see other support of different browsers as well. Now that we know from the caniuse.com that IE 11 doesn't support it, let's actually test it out in the browser. So on the browser, if I go and inspect element, and if I just refresh it, you can see that here it says intersection observer is undefined, and that is because this browser doesn't support it. So what we should be doing here is that in the else condition in the code, we are going to put another condition, and then we are going to say window.intersection observer, and then this condition should be working. Now for the browsers which do not support this, we are going to put another condition, and then we are going to use a third-party library here to handle the lazy loading for that. The library that we are going to use is lazy sizes, and this is also kind of mentioned in the article that this exercise is inspired from. And if we look at the repository here, you can see that we have more than 15,000 stars for this third-party library, and the best part is that it supports IE 11 as well. One important thing for this lazy sizes library is that we need to do a couple of things to make sure that this library works with our images, and the most important thing is that each image should have this lazy load class, and it should also have this data source attribute. Now we already have this data source attribute in our code. All we need to do is to apply this class and then include this library in our code. So for that, I'm going to go to card item.js, and here we are going to just add this class which is lazy load, and now we are going to go to script.js and put the code which will be used to load the lazy sizes library. So first we are going to create a script tag. So we are going to say script tag, and here we are going to say document.create element. Here we are going to create a script, and then we are going to say script tag.src, and here we want to provide the value of the JavaScript file's URL. So we are going to just say equals, and here we are going to assign the value of this min.js URL link, and then finally we are going to append this to the body. So we can say document.body.append child, and here we can say script tag. Now that we have done this, we are just going to do a console.log, and then we are going to say works in IE 11. Let's save this and try this out in the browser now. So if I refresh the app now, you can see that we got the image loaded. We see the log here which says works in IE 11, and if I go to the network tab, you can see that we only have two images loaded so far, which is the first and the second image. So if I scroll down a bit, you should be able to see that we load more images as we go down. You can see that we loaded more images, and if I go further down, you will see that we will load the final image which is 125 here, and now it works as we expected. So now our lazy loading is working on both the modern browsers and also on browsers like IE 11 and whatnot. So you just learned 3 different techniques to lazy load images in your web applications. Alright, so I hope that you liked the video. If you did, give this a big thumbs up. If you're not subscribed to the channel yet, do it right now. If you want to support me with my work, you can always buy me a coffee at buymeacoffee.com, link in the description. And do let me know in the comments if you actually like this video, or if you want me to cover something else related to this Fun with JavaScript series, and I would be happy to. Until then, happy coding, and I'm gonna see you in the next one.